Okay, good morning to everyone. Uh, in the previous class, we were discussing about one problem. Uh, that problem is uh, related to the flowing full, and um, so they asked us to calculate what will be the velocity of flow and discharge when it is running half full. So it is typical problem. Many times it has been asked in the final examination. Um, so here, don't confuse with flowing full and half full. Most of the people they will think that okay, complete diameter should be taken, but they have asked us to calculate the velocity and discharge when it is running half full. So according to that, we have calculated the velocity of flow and the discharge. So now we'll start with the theory part of this module. So in that, maybe they will ask, uh, um, what is egg-shaped type of sievers? Sometimes they will use this kind of egg-shaped sievers. And so we already studied the circular shape of sievers. Sometimes, in some instances, they will prefer this egg-shaped sievers. So, the use of egg-shaped sievers is becoming absolute in these days because their odd shape, this is very important, their odd shape and stability. This is the two things has to be taken care when you are deciding what type of sievers it is. When it compares with the round shape sievers and the egg-shaped sievers, the stability of the egg-shaped sievers is more than any other sievers. The egg-shaped sievers give slightly higher velocity. This is very important. Why it is preferred? Slightly higher velocity at small flows. Very important. So one is, don't confuse it to these two words. One is velocity and one more is flow. When you say it is a velocity, sometimes the velocity will be very high, sometimes the flow will be very less. Don't think that if the velocity is more, the flow will be very high. Sometimes it will be there. Small flows. Then the equivalent circular pipe carrying the same flows. Of course, we know that the continuity equation, that is Q is equal to AV. Q is directly proportional to V, means as the Q is go on increasing, the V also go on increasing. But sometimes what will happen is that small flow, in the sense it may small flow with high velocity, higher velocity, higher discharge. So that kind of concept is there. But practically, we have to study all these two equations. The calculation of the areas and wetted perimeters of the sievers are very complicated than what we were using for the circular shapes and the egg shapes. Sometimes we already studied if it is circular, if it is how exactly it is area is equal to wetted, means um, the R is P by A, wetted perimeter divided by wetted A by P. Sorry, this one is A by P. So R is um, hydraulic mean depth, area, wetted area divided by wetted perimeters when we are calculating it. So this is for the circular pipe, what we are using it. Circular pipes. Then how exactly it can be calculated? For most of the egg-shaped sievers, the following formula that we have to use it. And very important, whatever the capacity is may be assumed to be equal when area and the slope are equal. To be equal when that assumptions we have to make when we are going with this sievers. So then normally we will use this formula. D1 is equal to 0.8393 D, where uh, small d1, this is the width of the egg-shaped sievers. Suppose the egg-shaped sieve will be up like this. It is not like completely. It is of this shape. Okay. The D is the width, what we are speaking. Width. And D is the diameter of the sewer at the same cross-sectional area. So the area A of the section in square meter, always it is. And remember this one, this formula. Whatever the equations are there, these are the empirical equations, and make sure that whatever the area is there, it is in square kilometers. The perimeter in meters and the hydraulic mean depths are in meters. So hydraulic mean depths are in meters. 2 units are in meter. Area should be in square kilometers, perimeter should be in meters, hydraulic mean depth in maybe using this formula. So area can be calculated with this formula, perimeter can be calculated with this formula. So if you substitute that values, you will get it. So R is equal to A by P, that is equal to 2 by 7 D1. If you substitute it, you will come to know this is nothing but R. There is no, you have to remember all these equations, because, and very important thing is that A, it should be substituted in kilometers, square meters. So P, it should be substituted in meters, and R, it should be substituted in meters. Then only all these empirical equations you will get. So take this problem. So when laid at, so this is the bed slope, what we are talking about, bed slope. So each carries of 1.5 meter cube per second. This is nothing but the cube. So then when you want to calculate the area, use the previous discussed formula. What is that? A is equal to 9 by 8 D1 square. So use this formula, where A is equal to 9 by 8 D1 square. So where A will be area of the sewer and D will be the D1 will be the diameter of the sewer. So assuming a self-cleansing velocity, see this one, assumptions we have to make it. Assumptions we have to make it. Then we already know that the self-cleansing velocity and the non-scouring velocity range I already given 0.45 meter per second to 0.9 meter per second. So you take the maximum value of this, means above this, if you go, the scouring velocity will start. So if you want to maintain both self-cleansing velocity, self-cleansing and non-scouring, so you have to maintain in this range. So then area is equal to discharge divided by velocity. Discharge he has already given. Area is equal to discharge, that is 1.5 meter cube per second divided by, so we have to assume that is 0.9. So then area we got it. So area is equal to 1.67 meter square. Substitute in this. So then if you substitute that, what we will get is that 1.67 9 by 8 d1 square, that implies d1 square is equal to 1.67 multiply by 8 divided by 9. So d1 is equal to square root of this 1.67 into 8 divided by 9. So if you substitute it, so you will get it 1.22 meters. So then vertical height that can be considered by using this formula. Vertical height of the egg-shaped receivers can be calculated with the 3 times the radius. So 3, this is 1.22 divided by 2. Why I am dividing it by 2 means here it is radius, but we got it as diameter. The vertical height we got, that is how much? 1.82 meters. So then we got finally the height. If you take the egg-shaped receivers, so this one is the vertical height, then this one is your the diameter. Okay. So this is very important thing is that in this problem you have to assume it as this value, very important. Sometimes you can assume 0.75, so average. Some people what they will do is that they will take the average and they will assume this also, that is also correct. So in the next class we'll start with the construction of sewers. Thank you.